So we've looked at solving by factoring or the factoring strategies. So now we're going to look at all of the other methods one more time and give you some more guided practice on that. So the first method, solving using square roots. When is this a good method? If you notice in the problems below, x squared is the only variable term. There's no other x term. So that is when it's a good method to choose. So what you're going to do is get x squared by itself. So I would add 18 to the other side and divide by 2. So I end up with x squared equals 9. And when I take the square root of both sides, I get that x could be positive or negative 3, because both 3 squared and negative 3 squared both come out to 9. On number 2, I don't want to FOIL this out because this is x squared. So my first step is to divide by 4 on both sides. So now I have all that stuff squared is equal to 20. Now I can take the square root of both sides. So I get just x minus 3 left because the square and the square root cancel each other. And then I break the 20 down into a perfect square and a non-perfect square. Square root of 4 is 2, and the square root of 5 is the square root of 5. So I have plus or minus 2 root 5, which is the square root of 20. So my final answer, I need to add 3 to the other side. So positive 3 plus or minus 2 root 5 would be my solution. So it doesn't always come out as a nice answer, like over here we had an integer, but that is considered an exact answer. So when is completing the square a good method to choose? Well, you need to have an even term in the middle here, and see how there's an x squared and an x, and it's also not factorable. So in this case, I add this value to the other side. So x squared minus 8x, I'm adding 20 to the other side and leaving some room in here. To complete the square, you cut the middle value in half, negative 4, and square it. So I'm adding 16 on both sides of the equation. I just made for myself a perfect square trinomial. A perfect square trinomial means that you're able to factor it using the same factor twice. So in this case, x minus 4 squared equals 36. And now I'm right back to solving by square roots. I can take the square root of both sides. So x minus 4 is equal to plus or minus 6, which is an exact value. So when I go adding 4, I actually want to take positive 6 and add 4, and negative 6 and add 4 to get my two solutions. So my two solutions are that x could either be 10 or negative 2. And if I'm going too fast for you, just pause the video so that you can catch up. This is supposed to be just kind of a quick run through again of the other methods. There's a video on each of these methods if you want to go through those videos again from virtual. On number 4, before you can complete the square, you want to divide through by that leading coefficient. So if not all of these terms are divisible by the leading coefficient, you probably don't want to use the completing the square method. You could use the quadratic formula, which comes next. So I get just x squared plus 4x minus 3. So now I can take that 3 and add it to the other side of the equation. Complete the square, cut the 4 in half, 2, and 2 squared is 4, so I add 4 on both sides of the equation. This is a perfect square trinomial, x plus 2 times x plus 2. So I can write it as x plus 2 squared equals 7. Take the square root of both sides, so I just get x plus 2 by itself is equal to plus or minus, I can't break the square root of 7 down anymore. My last step is subtract 2 to the other side. So my final answer is negative 2 plus or minus the square root of 7. Very similar to solving with square roots. It's the same steps at the end. Okay, quadratic formula one more time. So when is this a good method to choose? Well, it's not factorable, and I can't use the other two methods. And what are the three outcomes we could expect? So you either get one solution, no solution, or two solutions. So remember, we can talk about the discriminant. So the discriminant is just b squared minus 4ac. That's called the discriminant because it's what is under the square root. So when the discriminant equals 0, I only get one solution because plus or minus 0 is still 0. No solution when the discriminant is negative, right? Because I can't take the square root of a negative number. So there's no solution. Two solutions when the discriminant is just some positive answer, like positive 8. I can take the square root of 8 or the negative square root of 8. They're two different numbers. So let's look at these examples using the quadratic formula. A is 3, B is -2, and C is 10. So I'm going to take those three values and plug them into this formula. So the opposite of B, +2, plus or minus the square root, B squared would be 4 minus 4 times A times C, all over 2A would be 6. Does anyone see a problem with this problem? This is 4 minus 120. So this is going to give me a negative discriminant. So there would be no solution to this quadratic. It would have no x-intercepts. Any problems with number 6? So before I start, I really want everything on one side of the equation. So I actually should add the 6x and add the 10 back to the other side and make them positive. Now I've got A is -1, B is 6, and C is 10, and I can put them into the quadratic formula. Now would be a good time to pause the video and see if you can figure this out for yourself and then come back on and check your answer with the video. So the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A would be -2. This looks like 36 plus 40. So -6 plus or minus the square root of 76 divided by -2. Is 76 divisible by 4? Yes, it would be 4 times 19. -6 plus or minus 2 root 19 over -2. That doesn't mean a whole lot to me. I kind of like having a decimal answer that I know where the x-intercepts are. So if you want to find the decimal answer, feel free. Let's see, again, I have to put that 4 on the other side of the equation. So I really have 4x squared plus 8x plus 4 equals 0. Quadratic formula, A is 4, B is 8, C is 4. So the opposite of B plus or minus the square root, B squared minus 4AC all over 2A. So something kind of cool happens here. I get 64 minus 64. That comes out to 0. The square root of 0 is 0. So I really get -8 divided by 8. So in this case, I get one solution. The x-intercept is at -1. All right, let's see. So before you do some, let's see, the back page here is guided practice, but how about a couple reviewing of solving by graphing? So this first one is in vertex form. And when you're in vertex form, remember you can just read the vertex right from the equation. So this quadratic is going right 4, up or down 0. So I'm going to put my vertex right there at 4. It is flipped over and stretched. So let's remember our parent function, 0, 0, 1, 1, and 2, 4, and then obviously 3, 9, that's not going to fit. So instead of going over 1, up 1, I'm going to go over 1, down twice as much, down 2. And then 2, 4, I'm going to go over 2 and down 8. So I have stretched my quadratic upside down. Really, they wanted me to solve by graphing. What is the x-intercept? The x-intercept actually was at 4. It had one solution. It was at 4. All right, standard form. Remember, we have to do -b over 2a. I gave you a problem that was not very nice. Okay, maybe it'll work still. -b over 2a. Oh, I shouldn't have given you this example. So we might have to use our graphing calculator for this one, because when I plug in -1/2, what do I get? negative 1/2 squared minus 1/2 minus 6, negative 6.25. I'm not sure why I did that to myself, but negative 1, negative 6.25 is not going to have very nice x-intercepts up here. Let me show you how to find them on the graphing calculator. Plug your function into the graphing calculator. I'm hitting zoom 6. Here's my quadratic. Oh, it actually does it have nice x-intercepts? Maybe it does. Let's see, so if I go to second calculate 0, if I go to the left and the right of this x-intercept, oh, my 0 is actually at 2, 0. So x could equal 2. It was just kind of hard to see where this was going. And second calculate 0. I got to go to the left of this other one. It looks like it's at negative 3. Yep, so negative 3 and positive 2. It was just a tough vertex to get started from. So if I asked you this without a calculator, obviously I wouldn't give you a vertex like that, but always good to practice using technology. Intercept form, it gives you the x-intercept. So remember, it's the opposite of the factor. So I have an x-intercept at negative 2 and an x-intercept at 4. Halfway in between would be positive 1. So I want to plug in positive 1 for both of those x's. 1/2 times 3 times negative 3 would be negative 4.5. And actually, I don't really care about where the vertex is because don't I already have my x-intercepts? So my x-intercepts are at negative 2 and positive 4. The whole goal was to find the x-intercepts, right? That's what solve by graphing means. Okay, the last two I wanted to do with you before you've got some practice to do on your own and some applications and some homework. Practice converting vertex into standard form. Remember, we have to multiply this guy out first. X minus 1 times x minus 1. X squared, outer plus inner, negative 2x. Negative 1 times negative 1 is 1. Distribute the 8 over all of that. So 8x squared minus 16x plus 8. I still need to add 2 at the end. So my final answer would be y equals 8x squared minus 16x plus 10. Same a value, if you noticed. Should be. Okay, what about standard form into vertex form? If you don't like the way I'm about to do it with completing the square, feel free to just do negative b over 2a and find the vertex and write it in vertex form. But this is kind of an interesting way to do it. You're going to need this for pre-calculus. So you have 4x squared minus 8x. I'm going to move the 8 over, but this is a y equals problem. So I don't want to put it on the other side of the equation. So I'm just going to leave some space. I have to factor out this 4 because I don't want to divide the equation by 4 because it's a function. So the 4 still has to be there. So I just factor it out of these two terms. See how now I can complete that square by adding 1? Negative 1 squared is 1. What do I really have? 4 times 1. I really just added 4 to this problem. So this is a little bit funky, but to keep it balanced on this side of the equation, this is all one part of the equation. If I add 4, I want to subtract 4 to have a net gain of 0. So I really have 4 times x minus 1 squared plus 4. And if you had done negative b over 2a, you would have found a vertex of 1, 4, and we already knew the stretch value was 4. So you are going to take a look to finish 320. You're going to now complete 1 through 8, and then complete the other work. Thanks.